Fine. So now we got one class called rectangle, right? Okay. And so rectangle has got length and width. And our rectangle has, every rectangle has a length and a width. And now someone says, oh, we want another class called cuboid. And we want to define a class called cuboid, and cuboid would have length, width, and height. Okay, cuboid would have a length, width, and a height. So how do we define this class called cuboid? And so someone says, oh, this is becoming a case for inheritance, because we have length and width, two instance variables already defined for a particular class, and I am defining a class which will be using both of them. Fine. So let's do inheritance. Okay. So let's see, how do we use inheritance here? Okay. So we want to define a class called cuboid, right? So when you define a class, any class whenever you define, okay, the name of the class, and we have an option of saying, oh, what is the super type for this? Right? What's a super class? Whenever you define any type, the super types will have to be mentioned first. You want to inherit from here. Okay, so we'll say, oh, the keyword used is extends, right? And we are trying to inherit from rectangle. So if we write this code, yeah, what happens? How many instance variables will be allocated whenever we create an object of cuboid? Rectangle has two. Oh, we haven't yet declared. In this case, currently, there are two instance variables. Though I have not declared anything in this, there are already two instance variables associated for the object of cuboid. Okay, and they are because of the rectangle class, and then we are saying, okay, let's have additional member called height. Okay. And so we get three instance variables in this case. Okay, fine. Let's go for a constructor, and let's write a constructor. Oh, how many constructors in our superclass? Two constructors were there. Yes. Constructor with two parameter, constructor with one parameter. One parameter means length and width are same. Okay. Now we can write a constructor for cuboid. Okay. To create a cuboid, how many parameters will you specify? Three. Yeah. So what do we do now? One is, yes, we have the instance variables. Yes. So someone might try to write like this. Right, and so on. Okay. Or someone saying, okay, let's use this dot set dimensions. We got set dimensions also because that's in the rectangle. Whatever is in the rectangle class, see what is getting inherited. What's inherited? The variables, instance variables, and the instance methods. Static is not related to inheritance. Okay? Anything which we talk as static, it's not about inheritance because it's not about object. Static means it's not about object. Static is more like global thing sticking to that particular class or interface, whatever it is, whatever that specific type. Okay, we have to use the type name and the static name. And rectangle dot, what was that static method there? Count. Yeah. Get the value of count. Rectangle dot count. Okay, so it's a type name, not objects. Okay, and so inheritance is more about the object part. Okay, so yes, every whenever someone says C1, right, cuboid C1, someone has written a test cuboid. And you're writing a public static void main. Yeah, what do we do here? Oh, cuboid is a new type I have defined, right? And I can declare variable C1 and C2. Fine. Oh, I also have the type called rectangle. Oh, sorry. And they are types. There is a type rectangle already defined, and now I'm defining a type called cuboid. So we should be able to declare variables. Okay. Now what do we want? We want how do we want to use cuboid? C1 equals new cuboid. Okay, let's first set our requirements by using it the way we would like to be able to use it, and then let's update the cuboid class. Let's identify what operations we'd like to have, right? Yeah. Yeah, we'll come to that. Yes. Okay. Okay. Yeah. So while creating cuboid, maybe I create a cuboid of 7 by 5 by 4. What about R1 equals new 7 by 5? What about R2 equals new cuboid? Can I do this? Which is super type, which is subtype? Super type is rectangle. Fine, we are putting a cuboid in a place for rectangle, that's okay. Fine. Okay. Now, what about the methods you would like to have? Oh, they have the area method, right? That should be okay. Area of the cuboid. It's not about just calling the method, but we would like to actually print them. Okay. Okay. This will be R1 dot area, and someone saying, oh, just like we have C1 dot area, R1 dot area, even R2 dot area. Okay, these are some things which we are looking at. Yes, that's something we should be able to do. Okay, we would like to have some operation like this. Okay, so if you can print area when it's a cuboid, okay, when it's a cuboid, yeah, we would like to be able to print also other than area, length, width, height. So what would you like to have? Fine. We should be able to use the fine, fetch what is the volume of a cuboid. Okay. So we are interested in this thing to start working, right? So we are interested in adding a method called volume also. Okay, I'm just setting up a few requirements. Oh, I will need a method called volume. We should be able to create a cuboid with 3 parameters. Okay, and of course we started by saying, oh, our constructor will need 3 parameters. Okay, fine. Now whenever you create a cuboid, the allocation of variables related to cuboid will happen. Okay, whatever you put in cuboid, but even before that, since it is inheriting from rectangle, it is first taking care of the rectangle part. It has to first take care of the rectangle part. See to it that the rectangle related things are initialized. The length and width are getting initialized. Then in this case, it's a length and width. Okay, so whenever we have a constructor for any class, the first thing which you do normally will be super. Call the constructor of the super class and ask it to initialize the parameters which are related to the super class. Okay, so we don't do a initialization in this manner. Your first statement in a constructor would be super, and then take care of, so this class takes care of itself, right? The variables which it has defined. As far as the variables related to the superclass are concerned, let it be done by the constructor of the superclass. Right? You are creating a cuboid. You are saying this is a rectangle because you said it extends from rectangle. So if you are creating a new cuboid, the count for rectangle should be incremented. It's a rectangle. Since you have said it extends a rectangle, cuboid is a rectangle. That's a statement we have made. Right? Maybe you are not comfortable with listening at that, and that's correct. It's not a correct way of inheritance. But anyway, we are going ahead with this just to understand a few keywords and the usage part. Okay, and then we'll make the correction how it should be. Because the relation between cuboid and rectangle is a different kind of a relation. Okay.
So in the rectangle file,
yeah,
if we write instead of public static, if we write a private in a keyboard file.
Okay. Currently, yes, we have not looked at what is public, what is private. Okay, so I'm not touching that area at this moment. Okay. We'll come to that also. Okay. Yeah. Okay. Super length width. Fine. And then you'll say this dot height. Okay. So that's the way the constructor will have to be written. Now, one thing similar to use of this to invoke the constructor of the same class. Whenever we use this in a constructor, it has to be the first statement. Whenever we use super in a constructor, it has to be the first statement. If super is used in a constructor, it has to be the first statement. This was also a requirement for using this. Okay. Now mark the statement which I am making. In any constructor, the first statement is either super or this. In any constructor, the first statement is either super or this. If you don't mention any of those two, fine, then it assumes super without any parameter. Okay, so if I'm writing a constructor like this, right? So if I was writing a constructor, and suppose I comment this out, suppose I have just commented it out, okay, fine. Then it is assuming that your statement here is, okay, let me put it in the next line. It would assume something like this. So if you are not writing a super or this as the first statement, a super without parameter is assumed as the first statement, because it says I need to be initializing the first part. Before I can start initializing your variables or anything which you are mentioning, I'm first taking care of whatever is in the super class. I'm a kind of the super type. Fine. The requirements of superclass, fine, whatever is needed, that needs to be satisfied first, and then whatever additional things you are having, okay, that's the next step. Superclass first. Right? So yes, of course. So now suppose I didn't put that concept. Fine. Suppose I write like this. What happens? Will this code compile? Is this valid? Is super without any parameters valid? What is the superclass? Rectangle. By saying super without parameters, what are we trying to refer to? A constructor of the superclass without any parameters. Is it available? No. This is not a valid statement. This is not a valid statement. So just saying super without any parameter is not valid in our constructor here. Okay. Another thing here. So fine. So this is not going to work. Okay. Currently, yes, if you are writing a super without parameter, right, as a first statement, or it's like, oh, even if I leave it, okay, I was initially thinking about having a constructor where I was saying, okay, this dot length is equal to length, okay, and this dot width is equal to this, and you may be writing like that. Oh, that's not going to work. Okay, so suppose you were trying something like this, saying, oh, this dot width, right? Yeah. So if you write like this, it's invalid. First statement of constructor is important. What is the first statement of constructor? Super. Use the constructor of superclass. Fine. And other option is, if this is an overloaded constructor, I have an option of not using super but saying, oh, I want to use the other constructor. You may add more things after calling the same constructor or the superclass constructor. But any constructor, first statement is either this or super. Okay. So here, let me come back to the rectangle. Fine. So we did a rectangle class. We never use super or this in the constructor. Oh, we use this only, but we have not used super in the constructor, right? Okay. Yeah. This one doesn't use a super. What is it like? It's as good as saying this. Even rectangle class constructor, you were not writing it, but this is what the compiler has assumed. What's a superclass for rectangle? Which is the superclass for rectangle? Yeah. Object. It's the object class. So when you are fine, so if you are not giving a superclass for any class definition, it's as good as saying So any class definition, superclass, if not mentioned, has only one superclass. Every class has only one superclass, direct superclass. Okay. If you're not mentioning, okay, I assume this to be object. Any constructor if you're writing, first thing, I'm using constructor of the object class. Yes, in the object class, a no argument constructor exists and therefore it is working. When object class has a no argument constructor and therefore our constructors have super without parameter and it's fine. We defined our class rectangle, we didn't put the constructor, we have put some constructor there. It has parameters, there's no constructor without parameter. Any subclass, if it is heavy, right? Any subclass of a class which does not have a no argument constructor available, which is the case with the rectangle class here, in such a case, the constructor, the first thing we need to do is either use this or super explicit. Right? Explicitly, super has to be mentioned. And we have mentioned, and we were mentioning super here. Okay, and this is must. It's an error. This one is an error. Yeah, first thing in a constructor is, yeah.
And also it gives us a,
This one?
yeah,
No?
if we comment out the super.
Yeah, yeah, still this is still an error because when you are commenting, it is assuming the first statement as super. This is what will be assumed. First statement is use constructor of super class. Or it's an overloaded constructor, we are using constructor of the same class. And for example, yes, here you might be thinking about writing a cuboid, okay, where only the side is mentioned. I want to keep all the same, okay, side. And therefore, I might just say this. Okay, you may be putting like this. So this one is valid because I have a constructor with 3 parameters. But this one says, okay, I don't have a constructor in the superclass with no parameters. You are not writing like this, right? You are writing like this. But still, there's no this or super in the first statement. That means super without parameters. Okay. What about in the rectangle, in the cuboid class? Okay, I comment out all this. Let me just remove it. What do you think? Will this cuboid class compile? You will find that this doesn't compile. What is the reason? Why this class? It just says, okay, I'm extending from rectangle, I just need one instance variable. That's the only statement it has done, right? There's nothing more. It's not going to compile. You have a constructor because what if you don't put a constructor? Yeah, what is the attempt it will make? It will make an attempt of having a constructor for the class. It normally tries like this. Okay, I'll explain what is public later, but yeah, if you don't put a constructor, then the code which comes up from the compiler is, oh, I don't find a constructor. Okay, that means you want to have a constructor like this. That's it. You have a constructor. Oh, the first thing in a constructor, even if you are not mentioning, is this. So not writing a constructor for cuboid would have still meant this one. And can this compile? That super without parameter? Right? My superclass, oh, I don't have a constructor without any parameter, and therefore this is still a compilation error. If this is compilation, then this is also compilation error. Fine, yeah. And so constructors, right? Okay. So first thing is, so when clear why we are writing in this manner, when the constructor requirement. So yeah, we may have two constructors like this now. Okay. So cuboid constructor with three parameters. First thing it is doing is calling the constructor of superclass. So constructor of superclass should take care of initializing the instance variables from the superclass. Right? Then you do your rest of the things about initializing variables of the current class. Okay. Okay. Additional method. Yeah. You want to follow the getter methods. So we'll have a method to return height. I think here we have followed that convention of using the parameter name. Okay, fine. So let's say we are putting like this and return the height of the object. So what are the methods available? I can use length, I can use width, I can use height. Three methods. Also, I can use area method. Fine. My superclass has an area method. Okay. Yeah. Let's look at another concept now. And we have seen earlier in the rectangle class, set dimensions, overloading was done. Okay. Now we are following another aspect of object-oriented programming. We call it as method overriding. We override the method called area. Okay. Fine. All rectangles. What is the area method saying? It is length into width. Okay. But let's decide that for cuboid, if someone asks for area, we'll give it as length into height. For cuboid, okay. So fine. See what is overriding. In general, my super type has specified how it is to be done. But for this special case, so special case here is the cuboid. It says, okay, let's do it differently. Let's not do it the way all other rectangles may be doing it. Okay, for cuboid kind of a rectangle, because yeah, I'm just saying cuboid kind of a rectangle because that's what we mean when we are saying extends rectangle. It's a kind of. Okay, fine. So in this case, yes, what should I be doing? Let's fine. Let's do the work of overriding the area method now. Okay. So how do we override? Just define the method. Int area, and what do we do? Return this dot length into this dot okay, fine. So for all rectangles it is length into width, but when it becomes a cuboid it will be length into height. Okay, want to save this? Okay, let's save this code as okay, let's say cuboid.java. Okay, let's compile. Okay, Yeah. Okay, we haven't put a volume method yet. Okay, let's put the volume then. Int volume. And what is volume? Okay. Area into height. Okay, and then yeah, what are we doing? Oh, we are printing areas for C1, R1, R2, and then the volumes also, right? For volume for C1 only. Okay, let's try this out now. You got the volume method, it's working. Okay, go through the code just once. Yeah. Look at the code. So rectangle class has methods for length, width, height, get methods basically. It has method for area. Area was length into width. Cuboid says, in my case, area becomes length into height. Cuboid adds a method called volume, which is area into height. Okay. Yeah. Okay, let's run the code for test cuboid. What are the output we are looking at? Okay, now what do you expect? Cuboid area, C1 dot area. What will be C1 dot area? Length into width or length into height? Length into height. What is R1's area? Length into width. What is R2's area? R2 is a cuboid. So should it be length into width or should it be length into height? Huh? Right? Will it go by the type? What is, we are saying R2 dot area. So the question here is, should it go by the type or should it go by the object? Object is cuboid. Type is rectangle. So does it go by the type or does it go by the object? Right? Here, there's a difference. The type is just a super type. Object is a subtype. So when we invoke a method, which one will it be using? And that's why we have kept the third option, right? Okay, we want to test it out. So yeah, what are you expecting? According to the object, right? Yes, it should be according to the object. We are invoking method on a particular object. So the method has to work for the object. When you're doing it on an object, it's not by type. Type is for the compiler, whether this is valid or not. Right? See, we have got, see, whether the type is useful, right? Type is used, okay, so here, suppose this was saying R2. Yeah. What do you think? What happens? I'll first comment it out, this one. Okay, let's test this one only. Right? Then the three outputs, which, yeah, four outputs we are having, right? Okay. Let's compile. Oh, that's compiling. Let's run which one? Yeah, it's calling the construct of rectangle, all those output which are related to the construct of rectangle. Yeah, we have put those outputs. So that's anyway, that's coming. So that can be ignored. But the last four output, yeah, length and width. R C1 is length, width, height. What is the length, width, height? So length 7, 5, and 4. So this is 7 into 4, 28, right? Okay. So this is area according to cuboid. R1 dot area 7 into 5. Okay. R2 dot area. R2 type is rectangle. The object is a cuboid object. Area working according to the object. But this is where we, many times the term used is, oh, method binding is done at runtime. See, when someone says runtime, that means we are talking about objects. When someone says compile time, we are talking about the types. For compiler, type is known. It doesn't know the actual object, what will be coming. It may be a subtype of it. Yeah, this is the type I know. Okay, volume, what happened to volume? We would expect 7 into 5 to 4. It's not that. We got it as 7 into 4 into 4. Because what have we written? We have said this dot area into this dot height. When this is dot, when we say this dot area in cuboid, which area will it refer to? Cuboid. Cuboid area was changed. It's not length into width. Is length into height, which is in the superclass, available to me? And the answer is yes. Okay, fine. What we need to do is simple. Fine, just simply change in the volume. Yeah. What's the change? Sorry. Super dot area. One was super to invoke constructor. Another use of super is whenever there is a method overriding, right? You may like to use super. Okay. See, one more thing. Even if there was no method overriding, I was always free to use super. Okay. I'll put some comment here. Okay. What is available to me is I can use super dot length. I can use this dot length. I can use super dot area. I can use this dot area. Right? I can also be using super dot the method called length. No, we have the length method, and I can also be using this dot length method. Right? Super dot length and this dot length, what's the difference? Anywhere I can be using super dot length. I can be using this dot length. What's the difference? No difference. Whether you say super dot length or this dot fine, super dot method name or this dot method name, it can be tried for anything which is in the super class. Okay? There is no difference. As soon as you override any method, then the difference comes into existence. Or whether you use super or whether you use this, the difference is only it's the same till the point it's not overridden. This means what's available for this class. Super means how it was available for the superclass. You didn't override length method, it's the same. You didn't override area method earlier, so you said this dot length or super dot length. So writing super is available for everything in the superclass. I can't be saying super dot height, right? It's not in the superclass. For height, there's only one option, this dot height. Everything else, two options. Anything which was in superclass has two options. This and super, both are options available to me. And both will always mean the same till you override or you will shadow it. And yeah, using it like how it was available for super type. That's where we say super. So yeah, so this will solve our problem. Fine. Okay. Super dot area to this dot height. So we are not changing that overriding part. Overriding is okay for me. But when I override, I have both the things available. It's different for the current class. Okay. So if I want to use for the current class, I'll say this. Otherwise, I should have been actually using super. Okay. So fine. Yeah. So this one also, whether it should say this dot length or super dot length, they mean the same. Anyway, about the variables, we'll see it tomorrow. Fine, we'll continue tomorrow. Fine, but fine. Here, any questions? Yeah, no. If you have questions, you want to compile and run the code again? Let's compile and run it at least and see that it's working. Okay, so area got the volume got corrected, right? That's a change, right? Right. So related to inheritance, one is we have seen inheritance of a class. Fine. And related to inheritance, we have also seen overriding. Once you inherit, you can override. When use of keyword super, that's the main thing which we have seen. Okay. Fine. Use of keyword super. There's something called variable shadowing. Like what we did is method overriding, right? We can also do variable shadowing. Okay, fine. We'll continue tomorrow. Unless any questions are there. Yeah. So, okay. Fine.